Hi, and welcome back to Integrated Science. We are talking about the idea of energy and how energy can be transformed. And so today we're going to look at how to use our potential energy equation to help us solve how much energy an object has potentially with using our just equation, which is this one here is a little bit different from what I showed you in the notes, e.g. E for energy, G for gravity, but it's still our potential energy. We're going to use our mass, our gravity, and our height to solve. And so I'm going to practice a few of these with you today and hopefully get you started. This equation, both kinetic and potential, are very important because we use them quite a bit in the rest of the year to really kind of help us solve different types of equations and stuff like that. So let's just take a look at number one here. So it says, what is the potential energy of an apple with a mass of 0.053 kilograms? And that is 3.4 meters off the ground of a hanging of a branch. So let's just take a look at what we have here is that we have our mass, and we also have our height. And just remember, we're on Earth here, so we don't know of any other places that have any life of apple trees. So we're going to use that 9.8 as our mass here. So let's go back and take a look at our givens. So I'm going to plug that in here. So we don't know GPE, but we have been given mass, which is the 0.053 kilograms, which is good, no conversions there. We want to keep it in kilograms. And we have gravity. I'm going to make that small g. We'll talk about big gravity later, which is 9.8 meters per second squared. Let me square that too. And then finally, we have our height, which is at 3.4 meters. So we have enough information to kind of solve here. So let me grab this. Let's jot our formula down just so that we get used to using it. I'm gonna change it and use GPE just because I feel that is the one that sticks into my head the best. And so now let's plug in. Let's solve for this. So we can figure out actually how much potential energy this apple has. So we're going to take our unknown, which I guess I should have put up there too. I wonder if it'll let me. X, or GPE equals X. There we go. Now why that one went into black, I have no idea. All right, so X equals, we're going to take our mass, the 0.053, and we are going to multiply it by 9.8, our gravity, and then our height at 3.4. So we are going to take all those and multiply them together, and I end up getting, let's see here, times 9.8 and 3.4. And I get 1.76596. So I'm going to round that 7 up to an 8. So 1.8. And remember, once again, we're working with our energies. And so our unit of measure is joules. So I'm even going to, I know it seems like silly steps here, but just to make sure we fill in every box. So there we go. So potential energy is kind of nice. It's just really multiplication. Let's take a look at one, though, that would be a manipulation. That might be just a little bit different than what we're used to working with. And I don't have to go far. I can see it in the question number 2. So it says, if a baseball thrown through the air reaches a top height of 31.2 meters, producing 61.2 joules of potential energy, what is the mass of the baseball? So once again, we do not have to do any type of manipulation, but we've got that 31.2 for our height. We've got our joules, and we don't know the mass. That's what they want us to find. That was supposed to be a circle. That was terrible. But you get the idea. So let's once again figure out our givens. So GPE, we know this time. This one equals 61.2 joules of energy. Our mass, that's what we don't know. Whoops, sorry. our mass is going to be our unknown. Our G is still the same, 9.8 meters per second squared. And then finally our height, we do know at the 31.2 meters. There we go. Try to get that all in one box. Formula is still the same, so I'm just going to go up there and copy it and paste it right down. Maybe if, there we go. And so now let's plug in. This one's going to be a little bit of a multi-step just because we do have to do that manipulation. So GPE, we know, is 61.2 joules of energy. And we know the mass is our unknown. Gravity is 9.8, and the height is 31.2. So now we just need to simplify. So the first thing we're going to do is order of operations, in which we have 9.8 times 31.2, and I get 305, so 61.5 or 2 joules equals X, and 305.8. I'm going to round that up too. So looking at this equation, once again, we just have to think, how can I get X alone? And so we have X times 305.8. So to undo multiplication, we have to do the inverse, which is going to be division. So if we divide each side by 305.8, and then over here to 305.8 divide, that's going to cancel it out over here. So if you kind of think about it this way, is draw a line through these two. We've moved it over. So X is now going to be alone. And so the last step is just now to finish out this over here. So we're going to take our 61.2 and divide it by 305.8, and that ends up giving me, let's see here, 0.2, and then there's a whole bunch of other numbers behind it, but there's nothing for me to round up, so I'm just going to leave it as that. 0.2 equals X. And so once again, we were finding the mass. So that's the mass of the object. And think about it, that should make sense. It's a baseball, so it's pretty small, and we're measuring it in kilograms. And so if you want to double check yourself, you could technically put back in 0.2, multiply it by 9.8, multiply it by 31.2, and you should come up with that 61.2 joules of energy. And so there's always a quick, safe way to kind of check yourself with it. And so these are our ways that we're going to use potential energy in the class to show quantitative pieces of information. So we're going to work on the next couple of problems just to make sure that we get a good feel for it. So hopefully this was helpful. Thanks.